Finally, an innovative, revolutionary new application system for cellulose insulation has evolved called the Dry Pack Wall System from Parpack. This new system is simple, competitive, and best of all, it plugs the leaks. That will save you precious energy dollars. Batt-type insulation's R factor is affected by voids and by compaction or stuffing the batt tighter than design specifications allow.
The key to a successful Parpack installation is tight poly. There are two methods of poly application. One is called lip stitching and the other is the use of drywall shims. The drywall shim method is covered in a separate tape. In this tape, we're looking at the procedure of lip stitching. We're using a long wall as an illustration. This is a 2x4 wall,
Yep, go ahead.
9 foot in height. The applicator, after measuring out the poly, is attaching the poly to the wall loosely, taking the top plate first, extending the poly all the way out, and then draping it down to the bottom plate. The stapling is accomplished with 1-inch crown staples. In this case, the applicator is using a Simco stapler. We've used Stanley, we've used other types of staple guns, but Simco seems to be the fastest and the most popular with our field training people. Poly is attached at the lower base plate, just pulled down tightly by hand. No poly bar is used in this application. The sequencing of the staples is approximately every 3 inches. Again, the poly is just loosely stapled to the leading edge. Now the applicator moves to the center of the wall and begins the lip stitching process. And you can see that the staple gun is brought in on the edge of the poly, catching the lip of the stud. Some people call this side stapling, lip stitching. The terms are synonymous. You'll note that the applicator is doing one side of the stud first, moving down the wall. He'll reverse that procedure, come back to the center of the wall, and begin the encapsulation of the stud face. The purpose of this is to prevent cross-migration of the cellulose under the poly, and that would eventually interfere with the wall boarding. So the purpose of lip stitching and the purpose of the drywall shims in the other video on this technique is to prevent cellulose from getting under the poly on the face of the stud. So in this case, we're wrapping the face of the poly, lip stitching on both sides of the stud, lip stitching around electrical outlets, and creating a 6-sided box. The bottom of the plate is stapled, the top of the plate is stapled. In order to blow a wall to a 3.5 pound non-settling density, it is necessary to create a 6-sided cavity. It doesn't matter whether it's a 2x6 or a 2x4 wall cavity. You're stapling top and bottom, leaving a see-through cavity, totally lip-stitched and totally enclosed. This is a repetitious function, actually goes quite rapidly. Typically a home can be done in a day with poly, and in the second day the blowing is concluded and the entire project is finished. This is a close-up of the cavities above the door. Please note that regardless of the size of the cavity, all the way down to 1 inch, the cavities are lip stitched. The blowing holes will be inserted into those cavities. The fiber will explode in the cavity. The microfibers of the cellulose will get into every crack and void, actually driven in pneumatically, and that's where the phenomena of this system occurs, in that the microfibers of the cellulose find their way into every crack and void and seal. Around the electrical boxes, the poly is trimmed away, and then all of the wiring is encapsulated around the electrical box. and the cellulose, when it's blown in, will completely eliminate air infiltration around the electrical boxes. Applicator in this case is doing a closet application with a header above the window. The poly is stapled into place. Once again, the concept of creating a six-sided box in each cavity is achieved. Lip stitching on the interior of the stud creates drum skin tight poly. Each individual stud cavity becomes a six-sided box that will be able to withstand the pressure of the insulation being blown in pneumatically. Above the windows, the headers are stapled. Even though the depth of the header may only be 1.5 inches to 2 inches, it's critical that this area be lip stitched and treated as a stud cavity. Waste material in the corners are trimmed away. The next procedure is to cut the holes in the poly with a box knife, on which the blowing hose will be inserted into each individual stud cavity. Again, a custom blanket of high density blown in cellulose fiber insulation to a verifiable 3 pound, 3.5 pound non-settling density is installed. In the actual blowing application, the applicator inserts the blowing hose from the top down, blows the entire cavity. As he reaches the top of the cavity, he'll reverse that hose and move it up to the top. The compaction of the material, or the density to 3 pound density, will be dealt with at the bottom later on when he does a second application in a two-hole method. Note that the applicator is using a PVC tube which has been taped to the end of the blowing hose. That enables the blowing hose to come out of the hole very easily and then be reversed very easily. It also serves as a ram to ram the insulation into the cavity, and as it's withdrawn, the tube fills the displacement area from where the hose and the blowing tube has been removed. Notice that the applicator does not turn the blowing machine off. He does not have a remote control in his hand. He's relying upon the individuals feeding the blowing machine to respond to voice commands in turning off the machine. He simply puts his hand over the end of the blowing hose for a split second and moves the blowing hose on to the next cavity. Note that the applicator is now returning to each stud cavity and re-entering the cavity with a slit at just above the knee level. He inserts his blowing hose back into the cavity using the ram and using the pneumatic pressure to assure the proper density in each cavity. Once the blowing procedure is completed, the wall is wiped clean and then duct tape is applied over each entry point, top and bottom. The wall is ready to be sheetrocked at this point. The applicator is testing each wall cavity, striking it physically with his hand. Any movement of material behind the poly tells the applicator that more material is needed. Openings down as small as 1 inch cavities. The applicator is attached a pop bottle to the end of his 2.5 inch diameter blowing hose and used it as a reducer to be able to enter the small cavities. It's important that the machine operator reduce the material flow gate to avoid choke points of the machine at this point. This is a double wall application which is used by builders, especially in large custom homes where laundry rooms and lavatory facilities on the inside of homes. Gets a double wall poly application, lip stitched on both sides. Note that the plumbing and electrical are encapsulated between the envelope of Parpack reinforced vapor barrier poly. Once the poly is lip stitched on both sides and is drum skin tight on both sides of the wall, Then the applicator will insert the blowing hose into each cavity and blow the cavity, creating a noise reduction coefficient of 40, which translates to a 75% reduction of sound in a 2x4 wall cavity, virtually eliminating sound transmission through the walls and providing the necessary insulation around plumbing to avoid any winter freeze-ups and cold drafts around the electrical outlets. We move now from Missoula, Montana to northern Minnesota, where a major utility company has selected Good News Reuse cellulose insulation for this project. The home will be open for 2 years to the public, thoroughly instrumented for energy load measurements. It's an all-electric heated home. These are engineered trusses. The poly, reinforced Parpack poly, is anchored. Sections of poly, 10 foot in width, are added together to cover the entire garage ceiling. The poly is lip-stitched onto the ceiling. The entire cavity above the engineered trusses will be blown with cellulose fiber insulation, not dense packed, but blown to the full height of the cavity. This is a specification from the utility company that we complied with. Plumbing pipes, electrical wiring, all of this will be encapsulated right up to the raised surface, plywood raised surface above the ceiling. There's living area above this area, and all sound will be eliminated. In this underfloor application, a slit in the poly is opened up, the blowing hose is inserted into this 12-inch TGI engineered truss cavity, and the blowing sequence begins. The equipment used in this illustration is a Promax 9218 that blows 1,280 pounds of material per hour, or roughly a bag a minute of product. The entire 12-inch cavity is filled. Approximately 400 bags of cellulose fiber insulation were used in this entire building installation. We now move to a engineered truss vaulted ceiling. The poly is attached in the same manner in which it's attached to the underfloors or to the vertical walls. Poly is anchored, creating six-sided cavity, poly anchored at the base, at the top, and then lip-stitched at the sides. The blowing hose is inserted into the lower portion of the cavity. The blowing is dense packed. The applicator will insert the blowing hose all the way to the top of the cavity and slowly begin to withdraw the blowing hose down from the cavity as the machine dense packs that cavity. Ventilation over the top of the cavity is accomplished with rigid polyisocyanurate stapled to the trim board on the engineered truss. Here you see the cellulose being dense packed, compressed into the cavity. The new process of making the cellulose insulation is called fiberization. Years ago, this was done with a hammer mill. And in the hammer mill, it would drive the material, the recycled newspaper, through screens that left visible pieces of newsprint. The old joke in the industry was you could reassemble your Sunday newspaper if you had some patience. But with this new system that I was involved with the development of it up at a company called Haybuster in Jamestown, North Dakota, a number of years ago, we developed the fiberizing process, and you can actually see the fibers. Now, what that is the original wood fiber, and so this starts out as a tree, and from a tree it becomes your Sunday newspaper, the soft sheet paper. We don't use the glossy paper. And then in the first stage mill, it's impregnated with a liquid fire retardant, and then in the second stage mill, it's taken down, fiberized, and then treated with a dry borate chemical. So you're dealing with the 2 stages of chemical impregnation into the fiber. Well, the fiber is cellular, hence the name cellulose.
One thing we all fear is fire. Our cellulose insulation dramatically slows a fire's penetrating capabilities for a very long